This video will show examples on how to work with complex numbers. Write the square root of negative 64 as an imaginary number. Remember our formula from the lesson said that the square root of negative r equals I times the square root of r. So in this case, we have the square root of negative 64 equals I times the square root of 64, or 8I. Solve x squared plus 9 equals 1. We want to isolate the variable, so we'll subtract 9 from both sides. And now we take the square root, so x equals plus or minus the square root of negative 8. At this point, we have to convert the square root of negative 8 into an imaginary number. So x equals plus or minus I times the square root of 8. Or in simplest radical form, plus or minus 2i times the square root of 2. Simplify negative 3i times 4i. We can use the commutative property of multiplication and rewrite this as negative 3 times 4 times I times I. So the first two terms multiply to negative 12, and I times I is equal to negative 1. So we end up with 12 as our answer. Negative 3i times negative 2i. We can use a similar strategy here, so negative 3 times negative 2 times I times I times I. And then the first three terms multiply to 18. We can group the first two i's together, say that they multiply up to negative 1, and then we have one I left over. So this is just equal to negative 18i. Simplify 1 plus 3i times 2 minus 2i. Here we can go back to our formula FOIL. The first terms are 1 and 2. Outer is 1 times negative 2i, or negative 2i. Inner, we have 3i times 2, which is 6i. And last, we have 3i times negative 2i, which is equal to negative 6 times I squared, or 6. Then we just add all of these together. So 2 minus 2i plus 6i minus 6. And that gives us negative 4 plus 4i. Finally, we want to divide two complex numbers. So the first step is to find the complex conjugate of the denominator. The complex conjugate of 3 minus I is 3 plus I. So we take that and multiply it against the numerator and denominator. So on top, we can use FOIL again. First, 1 times 3, or 3, plus outer, 1 times I, or I, plus inner, 2i times 3, 6i, plus 2i times I, or 2 times negative 1, or negative 2. And then in the denominator, using our difference of squares formula, we end up with 3 squared minus I squared. So this reduces to 1 plus 7i over 9 plus 1, which is 10.